Hi, I want to welcome you all to this JupyterCon session. Our session is called Assert Browser Test Equals True. And as the name suggests, this is all about testing JupyterLab extensions through your browser. And we're going to use a framework called Selenium to do this. My name is Shreyas Dalia. I lead a software group at Lawrence Berkeley National Lab.
And I am Labanya Mukhopadhyay. I am a UC Berkeley student, and I worked at the Berkeley Lab this summer as a software intern.
And also working with us has been Roland Thomas, who's done a lot of the integration work with Jupyter at our center. It's a little bit of background. We are part of the Lawrence Berkeley National Lab, which has a supercomputing center called NERSC, which is the Department of Energy, Office of Science, supercomputing facility. It's the primary supercomputing facility. And Jupyter plays an important role here in enabling scientific computing for a lot of our scientists that want to do interactive work with these supercomputers. And towards that end, we're building a lot of JupyterLab extensions that help them with these kinds of interactive workflows on large data sets and compute tasks. So quick disclaimer, I'm not a Selenium expert. We're learning these tools as we go. And so we realize that we're a pretty small team, and so we need as much automation in our system as possible, and Selenium seemed like a good choice here. So we're figuring this out as we go, but hopefully we can share some of our experiences with you all. So a quick word on JupyterLab Extensions. So JupyterLab Extensions, hopefully you're all familiar with what these are, but if you're not, these are things that can customize or enhance any part of JupyterLab. So every time you see a new theme or a file viewer or a special purpose editor, all of these things are implemented as extensions. Really, all of JupyterLab is just a collection of extensions that are plugged into the backend JupyterLab extension framework. But for this discussion, we'll kind of focus on front-end extensions that were custom things that we have written. So an example would be the Slurm extension that we use to interact with our supercomputer. So let's talk about the problem we're trying to solve, right? So testing extensions is tricky, in particular when you're talking about UI-based tools and extensions. This functionality is actually integrated across the browser UI all the way back to the JupyterLab backend. And a traditional unit test is not going to tell you if something is broken in this sort of end-to-end UI-based integration. If you click on something, you want to make sure that it returns the right thing and performs the right action. So in our case, we get a lot of pull requests. We get things like security updates from GitHub. We get version updates for packages. We want to be able to reliably test these things and make sure that this doesn't break our UI. And so that's where Selenium comes in handy. And to kind of set the stage for this, we're going to use an extension that we've worked on called the JupyterLab-favorites extension. This is something that allows you to save your favorite files and folders in the JupyterLab file menu and gives you a way to bookmark them. So it's a pretty useful extension, both in the context of a large supercomputing file system, but also your home computer. So if you're interested, check out the extension. So our use case is to make sure that this extension still works when someone makes some updates to the code. And really what we're trying to do is capture these kinds of UI interactions. So here's an example of the extension in action where we're adding a favorite, and then we want to make sure that this actually goes into the menu. And so we want to be able to replicate this kind of functionality, make sure this thing does something reasonable in an end-to-end sense from the user's browser. So this is where Selenium is really handy. Selenium is a tool that lets you automate web applications, particularly for testing purposes. And you can use code to drive these kinds of user interactions using an actual browser. And so the components of Selenium, we've got the Selenium WebDriver, which is the thing that actually starts up the browser and drives the interactions through the code that you've written. There's the Selenium IDE, which is the other side of the coin. It's a browser plugin that lets you capture existing interactions and record that as code. And finally, there's the client API, which are basically language-specific bindings. So that's the code that you're going to write your tests in that drive these things. So before we go any further, let's just talk about how to set up Selenium. We're going to use Python to write our tests, and we use Firefox because, yay, open source. But Selenium has support in multiple languages, support for multiple browsers, so there's also a Chrome driver that lets you do similar things. Go to the Selenium website, download the drivers, download the IDE, And the Python client bindings, you can just do a pip install or a conda install to get those. All right, so what does the actual test look like? So here's some actual Python test code that shows you kind of how these interactions work. So we have a driver that we kick off. This is the Firefox WebDriver that we use. We tell it to go to a URL, and then we ask it to look for a certain CSS element, in this case a span that has the word tests in it. We perform a double-click action on it, and then finally we verify that on doing that, it popped up an appropriate element, which we assert has a specific piece of text. So we're going to move on to the other side, and Lavanya is going to actually walk you through this example. This is all about recording your tests to generate the sort of code that you just saw. And so you're just going to record your session in Selenium. It'll capture all the browser interactions, and then finally you'll export that out to a file and fine-tune your tests in the file itself to be more useful. All right, so Lavanya, do you want to walk us through this?
Yeah. So here we are recording a new Selenium test session. We provide a name, and we give the URL of the browser that you want to test on. And then we start recording. So basically, Selenium will record all of the user's actions and interactions in the browser. So here we are adding test file to the favorites section. And we can make sure that this test file is actually being added to favorites using the Selenium assert text menu option. So now that we have finished this test, we can provide it a name, and then we can export it. So once we export it, we can open it as a Python pytest file. So we'll be able to see the Python file. We have the URL, the local host, and then we have the actual element selector. So this element right now is a CSS selector based on its position on the website. So instead of that, we can actually go into this browser using inspect element, and we can find a better way to kind of locate this element. So here we are copying its class name, the JP favorites item text. And with this, it's basically a more durable way to find this element instead of the position it's located on the website. So here we are replacing the CSS selector with the class name.
All right, great. So now that you've recorded your test and you've fine-tuned it, tweaked it, as you do more Selenium work, you'll get better at doing this as well. You have your test suite, we're going to run it and launch it. So this is all very straightforward. It's kind of your standard Pythonic way of doing things. So you launch JupyterLab in the appropriate directory, and the tests are going to run against that. And then you just use pytest as your test runner. And this will basically just automatically run everything in the browser, and you don't have to do any of the interactions. The Selenium and the browser will just take care of everything for you. So go ahead, Lavanya.
All right, so here we are using terminal to fire up the JupyterLab instance, and we see that it's going through all the interactions on the test. So then we run the pytest command in terminal, and this will run the two tests that we have created here. The first one, it'll go in order. So this is the first test that it's running. It'll automatically click all the interactions and user actions that is specified. And here's a second test. And basically, it's asserting that all the elements in that test were in place.
So that's great. Selenium has actually, let us run these browser interactions directly without, doing anything, just using your standard test runner. So, before we move further, I just want to give you a few gotchas in terms of what you want to be careful of when you're doing things in Selenium. So the first thing I want to point out is make sure that your tests actually are using persistent names and tags rather than positional references, which Lavanya just showed you. The other thing to do is to make sure you don't leave state around in doc files. So in the case of our favorites extension, we'll often leave like the marked favorites in there. So you want to start from a clean state as much as possible. When you're running your tests, you may need to wait for a JupyterLab rebuild because JupyterLab likes to rebuild its assets sometimes. So keep that in mind. Watch out for JupyterLab workspaces. So if this is the thing that you get if you have multiple browser tabs, you could have different views, which could mess with your setup. It's probably a good idea to disable authentication in these test setups. And so the quick and easy way we found to do this was to just set the notebook app.token to be an empty string, and then it won't bother to do any of the authentication when it's running the tests. And finally, you want to run with a local host on a different port as much as possible to avoid, again, dealing with existing installations that are running. Make sure you kill things when you're done, just standard stuff. All right, so now that we've showed you how to run this, let's talk about the bigger picture. How do we bring this into a continuous integration framework? So CI, or continuous integration, typically lets us automate the running of these kinds of tests. So every time you have a pull request or a git push, it'll automatically kick off a build and a test that runs in something like a Docker container in the cloud. And that's sort of the development workflow that you have. So we're going to use Travis CI for our work. You could also do very similar things in Circle CI or the GitHub Workflows framework. So in order to configure this, you typically just tell GitHub that you want to add this Travis CI application. You'll add a travis.yml file, which includes things like dependencies and stuff. I'll show you an example in a second. And just doing these two things, adding the app integration and dropping a YAML file, that's all you need. And now every single commit will automatically trigger a build of your tests. So here's that example Travis YAML file that I talked about. There's a lot here. I'm not going to unpack all of this. But the idea here is that you set up your image, your language, your environment, the add-ons that you have, like Firefox, the additional services that you want to run, and then you go through all these install steps for things you want to put into your image, and finally there's the test script that you actually want to run. And so here's a little thing that I think is an important piece of this equation, which is going headless, right? So what does that mean? So we need to run in a remote CI environment, typically a Docker container, without access to a physical display or a monitor. And so we have this tool called xvib, which is a tool which lets you set up what's called a virtual display. So you can run headless without an actual physical display device. And then the browser basically runs without an actual UI. And xvib just captures all the I/O for you. So that's a really nice way to just run remotely on the cloud. And so we just prepend our test script with xvib run, or in the case of Travis, you would just fire up the xvib service. So back to our use case, like I said, you'll need to just approve Travis CI and GitHub integration. You just add the travis.yml file. And now when you have a pull request, it'll automatically trigger a build. And that looks like this, right? So you go to the Travis page, and it's doing this build in the Docker container. And finally, you'll see in your build that all your tests ran and passed in the cloud. And if you go back to your pull request, it says all your tests have passed. So we should all be very happy. All right, so that's all we've got. Takeaways here, you can use Selenium IDE to capture interactions as code and then fine-tune them into a test suite. This approach is really useful for capturing these kinds of small updates. Probably not great for things like major JupyterLab updates where UI elements get moved around. In that case, you'll probably have to rewrite your tests. And finally, using something like xvib and headless mode, you can actually take this approach and just run it on a remote CI framework. Then before I go, maybe this is just a plug or a request. We'd like to see a lot more, hopefully, in terms of testing frameworks in JupyterLab, especially because it is such a browser UI-heavy tool. I think we would love to see more work in this area and have a better framework for this. So we love Selenium, and maybe something that's more integrated with JupyterLab and Selenium in the future would be great. All right, that's all I got. So I want to thank you all for listening, and feel free to contact me if you have email, and hopefully there'll be some sort of an interactive session where we can chat some more. So thank you.